Hello, my name is Gastón Hillar, and today I'll be focusing on an old protocol, but that became really very important with IoT, which is an MQTT protocol. Um, it's a lightweight protocol that became more popular when IoT started to explode. So we are going to focus on the MQTT protocol on Intel IoT architecture. I'm an Intel Black Belt developer since 2009. So it's been 8 years as an Intel Black Belt software developer, and I'm working as CTO at Mapgenics. So I'm working with mixing maps with IoT, with artificial intelligence, and all these kinds of protocols around to make things run smooth. And today, I'll try to explain you why you should pay attention to MQTT, and obviously we'll be working on Intel architectures. I have here with me an Intel Joule board, so you can see it's up and running. It's connected to Wi-Fi to my wireless router. So I'm going to be working with SSH Beauty, a Windows client for SSH, but you can connect with SSH with Intel Joule. But everything I'm going to run is not only going to be able to run on Intel Joule board, but also on other Intel IoT platforms like Intel Edison and Intel Galileo Generation 2. So in case you don't have an Intel Joule board, you can work with these other platforms. So everything is going to run on the different Intel platforms. In fact, I've been working since Edison was launched and Intel Galileo with the different platforms. So this is going to work okay with any of these boards you can have. So first I'm going to show you some slides, but I'm not going to get you bored with all these slides. I mean, I'm going to be very quick with the slides because I just want to understand why MQTT, why are we interested on MQTT? That's an old protocol again, but now we want to use it for IoT. So I'm going to switch to the slides. MQTT, we're going to work with the latest version with it, which is MQTT version 3.1.1. We can consider it a lightweight protocol that's very suitable for IoT. It runs on top of TCP IP stacks, and we can run it without security, which is obviously only for development cases, but then we can run with TLS to enable security and encryption. And we can work with a really secure protocol, which is still lightweight. However, we have to pay attention of a few things of this protocol compared with other protocols you might be working with. As you know, when you upload files with HTTP and you do things with HTTP, there is some kind of a lot of overhead that comes with HTTP. So here it's when you don't need that overhead and you need something more lightweight, is where MQTT becomes really an important option that we can consider. And in this case, for example, I'm going to focus on the architecture and the publish-subscribe pattern from MQTT and make you understand when this protocol can become a nice option for your project. Just imagine that we have to send simple messages. For example, we are sensing temperature with a temperature sensor connected to to an Intel Edison board. This one is going to be our publisher because we want to publish temperature sensed by this sensor, and we want it to be published to many different clients, in this case, mobile clients like an iOS smartphone, an iPhone, and an Android tablet, and many other clients like this. We don't want to have a heavyweight protocol. We just want to publish the values retrieved by the antigen sensor. In a publish-subscribe pattern, we will have something called a broker, but in the newest version of MQTT, it's called server. I'm using broker because if you read some literature, you will see broker. So the broker is equivalent to the server. So this broker receives the value published by the temperature sensor Y to Intel Edison, and through MQTT. The, the publish that takes place between the publisher and the broker can have a quality of service. MQTT works with three quality of service 0, 1, and 2. I will explain the difference and focus on quality of services 0 and 2 to show you the difference and make you understand why they are useful in which cases. However, when the message is received by the broker might have subscribers with different quality of service. That means a subscriber can select a quality of service for the subscription that is different than the quality of service we have used between the publisher and the broker. So this is a very important thing that we have to take into account with MQTT. MQTT doesn't work with the quality of service that's overall from the publisher to the subscriber. Instead, it's split in two. We always have a communication between two pieces. In this case, the publisher communicates with the broker, has a quality of service, and then the broker communicates with the subscribers, with each of these subscribers, and with different quality of services. We could have the iOS smartphone requesting a quality of service of 0, and the Android travel can be subscribed with a quality of service of 2. So this is very important because it depends on the networks we are using and how reliable they are. We could want to use different quality of service. The nice thing about MQTT protocol is that it's lightweight and it allows us to select different quality of service based on the scenarios in which we're working, as I mentioned before, depending on the network. So it is suitable when we have a not so reliable network, where we can work with a quality of service of 2 and make sure that the message really reaches the Android tablet, for example, and they are not so reliable network, and that they are retries and that the message arrives just once. This is what quality of service 2 is going to make us sure that the message is going to arrive just once to the subscriber that requests quality of service 2. However, of course, if we want quality of service 2 in the entire stack from publishers to subscriber, we will need to work with quality of service 2 for the publisher's broker or publisher's server, and then when the subscriber subscribes to the topic. And when I mention the topic, it's very important to make an important thing there. This publish-subscribe pattern governed by MQTT, and that requires a broker or server, works with some kind of channels. The channels deliver the messages, so you can think about that when I publish to a channel, all the messages that they publish to this channel is going to arrive to all the subscribers that request a subscription to this channel, or to a filter that includes this channel. I explain with channels because the real name is topic, but the channels is a more common name to describe when you send messages using these kinds of containers. However, the topic is really what in MQTT literature you're going to talk about topics, not channels. And MQTT supports the concept of topic filters. So this means that I can easily subscribe to all the altitudes published by all the sensors that are connected to different boards. So I can use some kind of wildcards that, not some kind of wildcards, they're really wildcards that allow me to define topic filters, and I can easily subscribe to a topic filter and include subscriptions to dozens and dozens of topics. So the way I must organize my work when I think about MQTT is to define the topics to which I want to publish the messages, and then the subscribers have to think about which topics I want to subscribe to. So this is how MQTT works, how we split with a publish-subscribe pattern between a publisher and a broker or server, and a broker and the subscribers. This provides, obviously, the need of having a broker, a server, that makes all the management of these messages that are received and have to be published. So we can work with there are dozens of implementations, some MQTT servers, and now I'm start talking about servers because that's a real name you find in the newest implementation of MQTT, that's version 3.1.1. And one of them is Mosquito. Mosquito is an open source implementation of an MQTT broker that has many features, including the support for WebSockets when we want to work with a JavaScript and we want to work with web browser-based things. And it also supports TLS security. Remember, for those that are still using the wrong name, TLS, SSL, you know, I mean, all the programming languages have still all the APIs talking about SSL. SSL is not being used anymore. I mean, we're using TLS version 1.2 or TLS 1.1, but we are not using SSL. However, in many APIs, including many MQTT clients, we still see SSL as the name because the APIs are still compatible with the versions that we're working with SSL. But the nice thing is that Mosquito works with TLS, so it's a modern. We can use the modern encryption with a modern security. So this is overall the publish-subscribe pattern. I will be using a broker that's based on Mosquito. I will show you where it's running, how it's running, and basic configuration things. Of course, I won't be able to cover in just 1 hour all the possible configurations of Mosquito. However, I want you to have the overall picture of what I am doing and how you can use it in your own projects. I think that's the main goal of our session today, that you can understand which are the benefits of MQTT and how you can consider it for your projects and how you can think about this publish-subscribe pattern, whether it fits or not your needs, and whether you need these kinds of things of having the topic filters and this kind of things where you need different clients, heterogeneous clients, and support for different programming languages, which is the cool thing about MQTT that has this kind of support. So I'm going to move to quality of service. So quality of service has 3 possible levels in MQTT, and we could be talking about 2 hours of how each of one works. I'm going to explain basically quality of service 0 and 2. I mean, just to make things easier, and just to move to our real life example using the IntelliJ and working with Python as our programming language combined with Eclipse PAHO client. So quality of service level 0 just publishes a message. And if it's published, it's okay. And if it's not published, well, bad luck. Basically, this is quality of service 0. Obviously, there is an advantage of quality of service 0. Suppose that I have to publish a huge amount of messages to a topic, and if one message doesn't arrive at the destination, which is, remember, quality of service is between the publisher and the server, and then there is another one between the server and the different clients. So we have to publish a lot of messages. We don't really care about whether one message is lost because it's just measuring altitude or temperature and we're displaying it, and one message that's lost doesn't make a huge difference because it's not critical and we want to put it all overhead and we want to send a lot of messages. Well, quality of service 0 might be the appropriate solution. However, what about controlling and run? I mean, I want to control a run. I want to make sure that when I say move up, it's going to move up. And when I say turn right, 45 degrees. I mean, obviously, I'm simplifying how we control drones and saying turbine to move up, and it's not precisely the nice comment, but we don't want to be experts about drone. We want to understand how MQTT works. That's our main goal. So quality of service is going to make sure that we have exactly once delivery. And that's essential when we control something like a drone, because I don't want to go up 10 times or 2 times, have duplicate messages. When I say it lands to safe place, it's land to safe place. Or when say go up, it's go up. I just want the message to arrive once. Obviously, magic comes at the price, and we have to pay a price, which is an additional overhead, as always. I mean, like with security, whenever we want more quality of service on reliable networks, and we want to make sure that the message arrives just once, we have to pay the price of an additional overhead, which means that our lightweight protocol becomes a little less lightweight and a more complex, and with more communications like this one you can see in this slide. The publisher, in this case, Lattice4, is going to publish with quality of service to the MQTT servers. So the publish is going to have a publish packet that's going to have a publish receive response, and then when the publish receive response is received by the publisher, is going to send a publish release, and the server is going to go back with a publish completed. So this kind of going back and forward makes sure that the publisher knows that the message has really been sent to the server. The same happens if we move to the right-hand side and see what's going on between the MQTT servers and the MQTT client, the subscriber number 2 and subscriber number 2, the number 1 and number 2, sorry, with quality of service 2. We have a publish, a pub rec coming back to the server, then a pub rel that goes from the server to the client, and a pub that's a publish completed that goes to the server. So this way, quality of service 2 makes sure with this communications, these packet exchanges, make sure that the message has been delivered at least once, and exactly once, which means that we won't have duplicates. So a simple answer to a common question: why should I use quality of service level 2 and support this additional overhead? When I want to make sure that the message arrives exactly once, and this means when I'm controlling a run, of course, when I'm controlling a run, I want quality of service level 2. I mean, I cannot accept many comments to the run because I lose precision. I don't want to say move up. I mean, it's move up. Move up is just move up once, and we don't want two times. So this is more or less so that you have an idea of what it means for quality of servers to, and well, with how we can take advantage of the different quality of service levels based on what we need to do. So this is extremely important, because if you work with MQTT and you don't pay attention to quality of servers, or the typical confusion is of thinking that the quality of server equal to configure for the client is going to be propagated up to the subscriber. No, we have different quality of services, and this is extremely important because it's one of the main confusions that developers have with this protocol. So now I'm going to show you a basic configuration for a Mosquito MQTT server. I mean, please, if you have any kind of questions, I'm reading the chat, I mean, on a second screen, so you can put them on the chat, and I try to, if it's a suitable question for what I'm explaining right now, I can answer it what I'm explaining. But if it's a question that it's convenient to be answered later at the end of the session, I'll do that at the end of the session. So basically, that's how we're going to work today. So well, I'm going to move to show you a bit more how we are configured right now. So basically here I have a pretty session where I'm running the intellectual board. I'm running on the this is going to run everything on the intellectual board. So I have Python style here, and I have MQTT. I go back to this later, but I want to show how I have configured my things here. So, and I'm going to show you that I have installed. This is on Windows, however, Mosquito, the Mosquito broker, you can see here that's running. It's a service that's running, and it says Mosquito MQTT version 3.1. However, it's version 3.1.1. Luckily, those that coded the service have forgotten to update this label with the latest version, but it's the latest version. So I have a Mosquito broker running right now on this computer in which I'm talking to you all right now. It's not running on the intellectual board, it's running on this computer. So the intellectual board is going to communicate to this Mosquito broker. I'm going to show, I have the basic configuration for Mosquito. This is Mosquito runs on Linux and on Mac without issues. In fact, I'm not running on Mac today because there was an issue with Keynote, with the platform. So, but in case you have any questions related to Mac or Linux, feel free to bring here the questions, because I've been working with these platforms a lot. In fact, more than in Windows. I'm going to show a program files. Where is and that's it. Program files. I was there. Mosquito. In program files in Mosquito, and this is on any operating system, you will find a file that's very important. That's in Mosquito Conf. Mosquito Conf is going to be on other locations on Linux and on Mac OS, but basically in all the platforms you can configure Mosquito with just making changes to this configuration file. It's all the same for all the platforms, so it's really very, very simple. I'm going to show you the configuration file that I have right now. That's the basic configuration file, and I want to show you a few things. Right now, I have a listener on the default port for Mosquito, which is 1883. This is the default port. Let's have a better font size. Okay, so this is the listener that's configured, that's to the port, and I'm listening on only the MQTT protocol. However, if you pay attention here and have these lines are commented, but this is how simple it is to configure Mosquito to use TLS. Of course, I'm not going to dive deep in this, because I mean, if you work with IoT, if you work with all these boards, I know you can create certificates, some self-signed certificates for development, and you know what I'm talking about. So we have that certificate authority file, certificate file for the server, the CRT, and the key file server key. And also we can configure the password for the key. So this is, with just these lines, I could move to Mosquito over TLS. I'm not going to show how to create the certificates, because that could take a lot of time, and I want to show you how to work with MQTT and on Intel bars. But just to give you an idea, I'll also show you in the code how you can easily configure the TLS handshake and configuration, so that you know that we can move to MQTT over TLS. So the example, I'm not going to show it without security, but this is what we could do to use server certificate to enable TLS and encryption. Please make sure you never run in production MQTT without encryption for critical things related to IoT, because that would be really very easy to hack. So I want to make sure that you see the configuration right now. So this is the mosquito configuration. So I'm listening in port 1883. So we just want to make sure in case we're running firewalls to make sure that we enable that port on our network configuration. So that's what we need to do, and we can start running. Of course, I have installed Mosquito here, but it's very easy, the installation. So I'm going to show you now, and it's very lightweight, the mosquito server. So I'm going to show you a simple utility that's going to, I mean, there are command lines utilities related to mosquito, but but I want to be more graphical in this presentation so that you have a better idea on how to play with MQTT and how simple it is. This tool is MQTT FX. MQTT FX is really a very nice tool. It's based on Java FX. It's free, and really I found it really a very nice tool. There are other tools, but this is one of my favorite ones. So I show you with this tool how simple it is to connect to a Mosquito broker. And I'm going to show you the configuration. And let's go to the other screen. Sorry for this. So I'm going to connect to, it says, you notice, and this is why I mentioned the difference between broker and server. In this case, it's talking about broker. I mean, in new MQTT, it's server, but you will see broker everywhere. It's still talking about broker for the people that comes from the previous version. So here we see broker address. So it's local host. I'm running on my local computer. So the broker port is 1883 because I'm not using SSL TLS. If I use SSL TLS, it's very simple. I just have to enable and specify the certificate. The certificate files and the protocol version I want to run. So I remember we can run with TLS version 1.2. So now I'm going to use this basic configuration. That's the default for these tools, so to make things a bit easy. And I'm going to subscribe to a topic and publish messages to a topic with some simple messages. So I'm going to click on connect. And I'm going to subscribe, click on subscribe, and I'm going to subscribe to comments drone01. So this is going to be my subscription. I'm subscribing to this topic. It's not a topic filter, it's just a specific topic with a specific name. So I'm going to subscribe to it and receive all the messages. The right-hand side, I'm specifying quality of service equal to 0 in this case. So most of the cases you will work with quality of service 0 for the most, not just, but well, this is just to make things simpler. And then publish. I'm going to send a JSON command, which is command as a key and move up as a value with JSON command. This is just what's going to be sent. That's the payload. This is the payload for the message. Messages, the content for the message is known as payload in MQTT. So I'm going to click publish. And if I go to subscribe, take a look, and now we received the message called name command for the key, move up for the value in JSON. Now I'm going to publish another message that's going to be moved down. Click on publish, and I go to subscribe, and I can see move down. It's after move up, so I can see all the messages here. So I can see the different messages I'm subscribed to. This is nice. I mean, there are, again, command line tools that are very useful. In fact, I like to use all these command line tools too. However, I want to show you this with a graphical thing. It's easier to see in a presentation to work with these tools and just show 4 windows with all the command lines tools running. For presentations that are nice. Of course, when you need to automate things, you can use the Mosquito Sub and Mosquito Pub tools that allow you to easily publish and subscribe. So I can easily see the messages that have been received and the messages I'm publishing. Well, now I want to move to something more complex and say, well, I want to use Python. I want to use Python with an Eclipse Paha MQTT client to process these messages because I want to run some code in the Intel Joule or Intel Edison. Again, it can also run on Intel Galileo Generation 2. And I want to process commands to control run. So I'm going to show you how simple it is. I mean, to show you some code. This is code I borrow from one book I published, so this is why it's used all this. So screen and I can this one. That's it. Comment. Let's start with the comment. This is a Python file that defines the commands that I want to be able to process. And so I want to basically control a run. That's going to be very simple. And I'm going to have the comments in the way I just show you that, like a command key and a command value. That's so. The command key is the finest command, and there is going to be a successfully processed command key. That's because I want the board to let me know with another message when the command has been successfully processed. So basically. Then I have the command strings that take off, land in safe place, move up, move down, move forward, move back, move left, move right, rotate left, set max altitude, set min altitude. And we have additional things that I need to pass to commands. That's a key in degrees and a key in feet for the move right, move back and move up and move down. I'm going to use units. So it's not just a hello world sample that I'm showing. It's something a bit more complicated so that we understand how MQTT can be useful for these cases. So these are the command keys, the command values we're going to have. These are the constants we're going to use. So now I'm going to go to another simple code that's in here is the most important part. Well, I import the commands. This is a Python file. I'm going to run this code in the board. I'm going to run it in Intel Joule, and I'm importing the commands, and then I import Paha MQTT client, MQTT. So this is what I just need is the Paha MQTT client for Python that I can easily install with pip and pip and Intel Joule or any other Intel platform. So I just need to install the client and I can start working with it in Python. Then I'm going to use JSON and OS path to make it. I wanted this code to be multi-platform. I didn't want to run just on either when running Windows and when, in this case, the certificate path is still on Mac OS style or Linux style. So, but this is not going to run, but I just want to show you how easy it is to configure certificates and use the TLS. I'm going to use it without TLS, so to make your lives a bit more easy. But this is a code. You can check the code that you need to use the certificates and the other port. That's 8883. So we have a drone class that's going to print messages. In this case, it's just going to print messages for all the commands that are going to be processed. I mean, you know, with the UPN, in fact, there's been a very nice session on UPM libraries with Intel IoT platforms. You can easily and really very easily control every actuator, everything you need to do on the board. So it's not the focus of this talk in which I want to focus on MQTT. MQTT is our main goal. So the other things, I'm sure with the global IoT Devfest, you've learned a lot of working with actuators. So that's not for this talk. So forgive me for just printing a message, but I didn't want to generate a lot of message. So this just printed a message with all the all the values, and there is a drawn common processor that just specifies which is the common topic that we're going to receive, the process commons topic in which we're going to send back the results. This is where we are going to send back the results, the messages saying I process this comma successfully. And here is the magic about the connection with the client. We just create an MQTT client with protocol equal to MQTT version 3.1.1. This is a very important line because I specify I want to work with MQTT version 3.1.1, not with previous versions. I don't want the broker or the server to decide which version I'm going to use. I'm going to just specify I want the latest version. So this is what I'm doing with this argument. And believe me, it's important. I want to use the latest version, and I don't want servers to decide. This is something that we should always consider. The same happens with TLS, with all these. I mean, we want this version, and then we have to define the callback. This is very easy code if you ever work with callbacks with Python. If you haven't, it's very easy. I just define the onConnect on message that is going to be called. I define it as a static method so that it's not just it's object-oriented code. So the drawn common processor onConnect is going to run when the connection has been established with the server. Don't forget the connection is with the server. It's not with the client. There's no direct connection. Remember the diagram I showed you at the beginning. So this is where we have the on connection that has been established with the server that's going to give me the messages I want. So an on message, I'm going to run this drawn common processor on message static method that's going to run when a message has arrived for one of the topics to which I've been subscribed, or that matches a topic filter. Remember, topic filter was Wilcards. So then I call the TLS set. This is in case I want to run with the security. This is the line that makes the magic, and you're running encrypted. So basically, you specify the client certificate, client key, and with a configuration for the server. So, and then there is a client connect to the host, the port, and the keep alive argument. The keep alive argument makes sure the connection is keeping alive or not. It's a specific parameter from MQTT. I'm not going to dive deep on keep alive specifically just to keep on track with the time we have. However, it's an important parameter that all these parameters you should dive deep on a specific filter for MQTT, like last will and testament filters and all these kinds of things that I'm not going to cover, but pay attention. The protocol is really, really very nice in many filters for IoT. Let's pay attention to the onConnect method. It's going to say unconnected to the MQTT server and calls the client subscribe. That's going to ask to subscribe to the commons topic with quality of service of 2. I want to subscribe with quality of service equal to 2. And then I'm going to publish a message to the drawn common processor process common topics saying I'm listening to messages in the payload. The topic is a process commons topic, and the payload is what's the message itself that I'm going to see, in this case in MQTT FX. And then let's go to the on message, which is a complex method, but really very, very, very simple what it does. It receives just client, user data, and message. And the message includes the topic. So I can check the topic and make sure that the topic is the commons topic. Why I include this line, and this is very important with MQTT, because I can subscribe to multiple topics. So if I subscribe to multiple topics, I need to check whether it's for me or not. Because if not, I'm going to process everything that comes to me because I've subscribed to multiple topics, and the on message callback is going to run for any message I received in the topic. So you have to be careful. will receive a null message. Is going to run for all the messages that come from all the topics I subscribe. And when I start with the first example, I start with a single topic. But then I start adding features and I start getting more subscriptions to additional topics. I say, oh, it could be nice to have these topics here, this other topic for this other topic for this. And then we have code that's running, making the pool run go up 1,000 times. No, we don't want that to happen. Or process unnecessary times a lot of messages. So it's very important to check the topic that we receive. And it prints a message saying, okay, I received the following message with the payload string. That's a message payload decoded to UTF-8. So this is what we have. We decode to UTF-8 and we have the string to work with. Of course, I'm not making a lot of validations. I'm just saying, okay, I received the message and I do a message dictionary. JSON loads the payload string. If it's not JSON, this is going to not be the best code you want to use. However, please forgive me because we are trying to make it simple for the presentation, but this is obviously I would need to add a lot of validations. You will understand me, and I'm sure you will forgive me for this. But this is to make just things simple. And then we check the common key in the message dictionary. And if there is a common key in the message dictionary, and just say, well, which is the command, we retrieve the command, and we do, yes, we don't use a dictionary here, we just put if, else, if. It can be done better, but I just want to make sure that it's easy to understand and it's not a super algorithm that makes things complex. It's an if, and you can see and you can understand that if the command is this, it's going to run drone takeoff. If the command is that, it's going to run drone land and not a dictionary that then I have to explain you how it works. But this is just simple. It's an if, you can see it, you can understand an if for each of the command, and it runs the commands for the drone class. The active instance is going to be of the drone class, and if the message, there is a value error in JSON, the message doesn't include a valid command, that's it going to say. So remember, the commands that we're going to process are these ones that are here. These are the methods in the drone class: print with name, prefix, takeoff, land, insert. That all of them are going to print a message. So we just printed messages on the integer board. Then the publish response message method is going to just create a response message with a successfully processed command key and a message. The command key for the message we receive. So basically, this is it's going to call a publish for sub client publish with a topic and a payload. The topic is going to be the process comments topics and the response message that we will see in the board. This is for the backend process. We're going to see in the board what's going on, not just see the draw moving. And I forgive me because I'm not going to move the drone inside here because I'm going to break it. so I just show you the messages. But believe me, this solution worked for a real life drone, and where you need more space and it should be raining to show you it. Okay, so then the main method. Of course, we will. The slides will be short. Yeah, definitely. And the slides and the code both are going to be short. So for your question, Jamal, yes. Then we create an instance of drone called drone1. A drone common processor is going to be a common processor for drone1 and the drone instance, and a loop that's going to run while true is going to process commands every 1 second. So I'm going to now go to my PuTTY sessions. That's SSH in any other platform. In Windows, I'm using PuTTY, and I'm going to run. I have it here. I'm going to run Python, and I'm going to run the Python script. So this is going to establish a connection to the MQTT server. Of course, I'm replacing the code with the IP address of my computer that's running the Mosquito MQTT server. So now I have it here. I'm going to put it here, the connection to the MQTT server, and I'm going to run the tool here at the right-hand side so that you can see what's going on. And now I should say take off. So I can see the buttons with quality of service too. And here I can see I received the following message: command takeoff. And what does it say? It says taking off. So I can control my drone with commands with quality of service level equal to 2 from my computer. And this is the code that's running on the Intel Dual board that is processing these commands with Python code and the Paha MQTT client. So this is how simple it is. Notice that there were just few lines of code. I mean, I added complexity to these lines of code just to not show a hello world example that you can say, this is a simple example, and just getting, okay, this is hello world, but then when we have to do something like controlling a drone, it's not so easy. Well, we are doing it. The drone has taken off, and I can see the message, and look at this. I had made a subscription to and now I'll subscribe to the process comments. Look at this one that has comments, round 01 subscription, has received the takeoff comment too, because I'm also subscribed to this topic, so I can create responsive applications that provide a great information on the user on the comments that have been published. And because if I subscribe with quality of service too, I'm making sure that the drone has also received the message. So even on unreliable networks, of course, if the network goes down, and it doesn't ever go up, it's not going to receive the message. But well, that's another issue. And take a look at the MQTT protocol, because it has some nice features when the connection goes down, because we can configure the last will and testament message so that we can receive a message when the connection went down. And we can tell the user that in our apps that control drones and things like those in IoT. So it's very useful. And process comments. I'm going to subscribe to process comments. And now I'm going to send another comment. And it says, I received the following command: move up, moving up. And then I go to process comments, and look at this. We have process comments, move up. I can see the process comments, the comment that has been successfully processed by the drone. I've received a message in process comments, row 01, and I can see successfully processed comment, move up, a JSON message that I can use in my client-side application or mobile application to say the comment has been successfully processed. And just use a bit your imagination and the kind of applications that you can use for this. You're thinking about a dashboard. Think about the dashboard where you have a control panel of 10 drones, and you can see that which are the process comments that each drone has being processed by subscribing to process comments, and even show all the details or ask the drones about, tell me your altitude, tell me something, and the drone can respond to all these comments, and you can easily create an application that provides you a dashboard by using MQTT. The payload is really very reduced, the payload is very low, and we can use the different quality of services based on what we need to do. So this is a very simple, it's a simple example of how we can control a drone. It's a simple example of how we can use these features to easily run in Python code in an Intel Joule board, take advantage of all the power of Intel Joule. I mean, just imagine the number. In the case of an Intel Joule, but believe me that the Intel Galileo boards and Edison boards are extremely powerful running in Python or Node code when running, or Java code when running, and GDT is super lightweight. So it's really very, very fast, the processing of these messages, and it's really a protocol that you want to take into account whenever you have to work with IoT, with your IoT solutions. So basically, this is the idea with MQTT. Of course, you have some homework if you want to work with MQTT, because in this session, I cannot explain you all the features that you have with this protocol, but just this this sample and these things I explain about the quality of service and how the tools and MQTT effects that you can easily see the messages, subscribe, and really start up and running with MQTT without having to spend a lot of time reading the details about the protocol. So basically, this is an example I wanted to show you, and I want to show you the possibilities and to make you think about, well, how you can use it in your applications. MQTT is very appropriate for mobile devices where networks are not reliable. Mobile networks, even with 4G, 5G, or even 10G, they're still going to be unreliable in certain situations. So you need this kinds of protocols where you say, I need the message to deliver just once. Well, and this is what MQTT brings you. I've used it in many IoT solutions. Of course, it's not the best protocol for all the solutions, as always happens, and this is what we have to do as developers. Think about which is the best protocol for each solution, and not just HTTP for everything, or other gateway-based solutions, or what MQTT. Now you have another option in case you didn't know very well about MQTT, or in case you just heard about MQTT and said, well, how can I use it? Is it going to be too difficult? I'm going to have to learn all things to use it. Well, I suggest you taking this sample as a baseline, and you can easily start up and running. I use Python in this case, but you can use the same for any other client that uses the Eclipse. PAHO clients have for many other programming languages, so you can use them. So basically, well, that's what I want to show you. I want to show you in a real intelligent board. In really running on the intelligent board and not running on a local computer. And basically, well, this is what I want to show you today. And now it's time for you to make any questions, anything you'd like me to cover again that wasn't very clear. I have specific literature related to this. I'm the author of 2 books related to MQTT, specifically Internet of Things with Python. So in case you want to dive deep, I also have plenty of material there, but you can also get on the MQTT protocol and many other sources related to the Eclipse have a client. But well, let me know your questions. Any questions related to MQTT, to the sample, quality of service, security that you have. I'd be more than happy to answer them. Of course, there are some questions that probably I can't answer. I cannot answer everything, but well, what can I answer? I'd be more than happy to provide answers. My contact information is here. I have the Twitter account is Gastón Hillar, and my email gastonhillar@hotmail.com. I try to be responsive, so you probably won't get a response in 24 hours, but seriously, in less than 48 hours, I always answer emails and Twitter, so I'm more than happy to get in touch. The email is here is gastonhillar@hotmail.com, so get it there in the chat so that. Anyway, Internet of Things with Python is completely focused on Intel IoT boards. So it's not just with Python, but publishers like to change the names to make them more attractive. But it was Internet of Things with Intel and Python. But basically, so in case you want support for other boards, this is not the book that's going to provide you. It's all Intel based. So basically, most of my experience with IoT has been based with Intel platforms, and well, I come from the Intel platforms for everything. So most of my experience is everything with Intel. So in case you have any other doubts, make sure you send me an email or communicate with Twitter, and I'll be more than happy to provide it to you. And I really hope you enjoyed this talk and you have a better understanding of MQTT, and that you can get this information useful for the project, because that was the main goal, and I'm sure you've enjoyed Global IoT Devfest as I did. So thank you so much for joining, and see you in the next one. Bye. Have a nice day.